Hello class. So this video I'll be discussing the answers to the first example for kinematics in 2 to 3 dimensions. This is example 1. You can find this in the PowerPoint that I have uploaded. Okay, so the problem says a web page designer creates an animation in which a dot on a computer screen has a position of r, okay, as a function of time. So our moving particle here is a dot, and then let's say this space here is the screen where the dot is moving. So ito yung pinrogram ng programmer, no, ng web designer, na yung dot will have this position at any particular time. The first question is asking of the average velocity. Now take note, the symbol for the average velocity here no longer have the subscript x. Why? Because this is already 2 to 3 dimension na quantities, kaya walang subscript x. In the previous example, we always put the x value there, I mean the x subscript, because the motion there was restricted on the x-axis. Dito, wala ng x, ha? So, meaning, ito na talaga yung buong velocity vector, average. I hope you have read, no, that in 2 to 3 dimensions, so itong si average velocity vector will have the x, y, and z. Depende kung 2 to 3 dimensions. So, we are asked to determine the magnitude and direction. And since this is an average quantity, we need 2 time values. Pag instantaneous yung hinahanap, isang time value lang ang ibibigay. So, in this case, it's between 0 to 2 with this particular r. Now, take note that the I hat here, remember in our previous discussion, si I hat is a unit vector that points the direction of the x component. So, immediately, you know that this expression here is the x position or the position of the particle along the x-axis because of the I hat. And then you have here the 5t. The j hat here is telling us that this is the expression for the position of the particle along the y-axis. So this is basically x I hat plus y j hat. Okay? For the x component of r, before solving, no, you have to inspect. Si x component ng position, merong isang quantity na constant. So, itong isang term lang ang nagva-vary with the square of time. Okay? Yan si I. However, si y component of the position really varies with time kasi may constant ka tapos may variable t. So, pag nilagyan natin to ng any values of t, immediately the y position changes and the x position also changes because of this, but this remains constant. Okay, so how do we get the average velocity? Balik ulit tayo sa basic definition ng average velocity. Okay, so average velocity, no x is equal to what? It's the displacement, so it's the change in the position vector r. Kasi pag one-dimensional ito, it's delta x. Pero si r dito ngayon, it can have x, y, and z component divided by the change in time. Okay, just follow the definition. Delta means final minus initial. So this means, itong mathematical operator katabi ni r, so it's final position r minus the initial position. And then delta t ulit, operator t, you have final time minus initial time. Initial time 0, final time 2. Okay, let's further simplify our terms here. The final position, since the final time is 2, then the final position r here is the position vector when time is 2. And then the initial position here is r when time is 0. And then, of course, T2 final, this will be 2 seconds minus 0. And then, we will just substitute. So, R, when time is 2, you just use all of this expression and then substitute natin si 2 for T squared. So, it's a bit long, no? So, let me write it for a while. Okay, there you have it. Let me adjust this for a while. Ayan. So, this entire expression here, this is R when time is 0. Huwag niyo munang pansinin ito. So, this is r when time is time is 2. So, si t squared naging 2 squared, and this is x component of r2 plus 5, 2 ulit. Ito. Minus r when time is 0. So, 0 squared, 0 squared. And then, so ito na yung delta r natin. All over 2. Ayan. Okay? And then we simplify. Dito muna tayo. So, itong siya, 0 na ito. And this one also is 0. Okay? So, here we have 4 times 2.5. That's 10, 14. So, we have 14. And then, you have the I hat. Okay? Plus, this one, 10j. Okay, so ito na lang yung natira for r when time is 2. And then minus, yung r when time is 0, ito na lang si 4 ang natira. 4 I hat, walang j component. 4 I hat, kasi 0 na yan. All over 2 seconds. Okay, so we now have here combine similar terms. No? We discussed this already in the early videos. So this becomes 10 I hat plus 10 j hat all over 2. And then this is now our velocity average in component form. So we have 5. Let's take a look at the number of significant figures here in the given. 1, 2. So I'll say this is 5.0 centimeters per second I hat plus 5.0 centimeters per second j hat. This is not our answer yet because, this is not the final answer yet because the question is magnitude and direction. Pero kung ang question lang, kung hindi hiningi si magnitude direction, sinabi lang find the average velocity, then this can be declared as the final answer in terms of component. Okay? So, what do you do to determine this vector if you know the components? What you want to determine the magnitude. Tapos may components ka. Yes. So if if you already know the components of a certain vector, you can just use again Pythagorean relation to get the magnitude. So to answer this question here, we'll simply use the Pythagorean relation. So, dito ko na lang muna isulat ha. So, for the magnitude, I'll say the absolute value, the magnitude of V average is equal to, you have the components here. V average X component, and then I'll square this, plus V average Y component, and then you square this. Okay? Because this is V average X, and this is V average Y. Okay. So, plugging in the values here. Okay. It's just 5 squared plus 5 squared. So, you have 5 square root of 2. And that would be, in two significant figures, you have 7.1 centimeters per second. This is the magnitude. So, if I do not want to use the absolute value symbol, hindi ko lalagyan ng arrow sa taas. So, this is the magnitude. Okay? And then, for the direction, okay, make it a habit, class, na pag meron kang hinahanap na vector, kahit anong vector pa yan, tapos alam mo na yung components, i-sketch nyo kaagad ang component, no? I-draw kaagad para meron kang idea kung saang quadrant siya, para mas madaling mag-declare ng final answer na direction. So, in this case, I both have positive I and J components here. Pareho ng magnitude. So, mathematically, we know that kung pareho si X and Y coordinate, ang angle nito is 45. Okay? So, let's just validate. So, sketch muna natin. Nasa first quadrant itong vector natin. When you graph, okay, make sure na ang estimation nyo realistic. So, kung pareho ito, pareho dapat ng haba. Okay? So, I'll have here, this is my V average X component. And then, head to tail ko siya kasi vector addition diagram ito. V av Y. And then, starting point to end point, that's the resultant. This is now the V average. And then I'll look for this angle. I'll call this theta. Okay? So take note that in component form, V average is the vector sum of these two components. Kaya, ang resultant nila itong hypotenuse. Tama ba? So, we already solved for the magnitude of this hypotenuse. It's 7.1. For the direction, it's just opposite is y, adjacent is x. So, I'll say that theta is, you have arctan, and then we will always use the positive, the magnitudes here. So, this will be 45 degrees. Therefore, in our final answer for average velocity, we now show it as a vector and then magnitude 7.1 cm per second going towards 45 degrees. This is standard position angle, so there's no need to write north of east. Okay? So that is now our answer for letter A.